Unit 3, Chapter 6. This is the last chapter of Area of Study 1 in Unit 3. Okay? We will look at some of the design features of fuel cells, including the use of porous electrodes for gaseous reactants, because that's quite common for fuel cells. Although the details of specific cells not required, but we will still look at 3 types of hydrogen fuel cells just for comparison and to know better the commonalities of all fuel cells. Now let's start. So first of all fuel cells are galvanic cells. They convert chemical energy to electrical energy. And in this case, it's a hydrogen fuel cell. So the half reaction for the anode is when hydrogen loses electrons to become hydrogen cation. Okay? It's being oxidized, that's why it is the anode. Okay? And the other half is where oxygen being reduced to gain electrons, and therefore that's the cathode. Okay? The overall reaction is hydrogen reacting with oxygen to produce water. Okay? It's just like if hydrogen gas is going through combustion reactions without the flames in this case. So for fuel cells, there's one thing that's quite specific, that's quite unique. That is their porous electrodes. Okay? So porous, a sponge is porous, so you get an idea what it is. Okay? So it must be porous as compared to other galvanic cells where it does not necessarily have to. Okay? It has to be porous so as to allow gases to come into contact with the electrolyte in the middle. And also the large surface area of such a porous material offers a site for reaction. Moreover, those electrodes often carry catalysts to speed up the reactions. After all, we are trying to utilize the energy from a combustion reaction without the combustion itself. Okay? Also, the two electrodes are connected by an electrolyte, which carries charges from one electrode to another. It's kind of like the salt bridge in normal galvanic cells, where it completes the inner circle of this battery. Okay? And also, later we will see this electrolyte will determine how you write your half equations. In summary, fuel cells utilize combustion reactions to produce electricities. Okay? Since it's a combustion reaction, oxygen is always being reduced. It's just in different situations, in different electrolytes, it could be reduced to either oxide ions when the electrolyte is actually solid, or it could be reduced into hydroxide when the electrolyte is basic. Or in a neutral or acidic environment, oxygen is then being reduced to water. Again, depending on the fuels used, the anode could be hydrogen, as we already seen before, or it could be methane, or methanol, or propane, etc. Okay? It depends on the fuel that you choose to use. Okay? And in the end, since it is a fuel cell, all the overall reactions is exactly the same as you would write in a combustion reaction. Yeah. Now, let's look at 3 types of hydrogen fuel cells to compare and contrast. We'll look at proton exchange, where the electrolyte is acidic. We'll look at an alkaline environment, where the electrolyte is basic. And then we'll look at an electrolyte that's quite special. It is a solid. So, proton exchange. So, it is an acidic environment. So, what you would do is hydrogen is the same fuel cell. So, hydrogen is again at the anode. But in this case, you are balancing it in an acidic environment where hydrogen is turning into hydrogen cation. And at cathode, oxygen is being reduced, but you're balancing it as you would in an acidic environment, which is water on one side as a product, and then you use hydrogen cations. The overall reaction is the same. They produce water. If we swap the electrolyte to a basic alkaline electrolyte, then the reaction is slightly different. So in this case, we're using potassium hydroxide as the electrolyte. We know that the overall reaction for all hydrogen fuel cells is hydrogen reacting with oxygen to produce water. So our anode reaction becomes hydrogen reacting with hydroxide to produce water. Okay? And our cathode reaction becomes oxygen being reduced in water to produce hydroxide. What if the electrolyte, the medium, is a solid? Then the half equations again are different. At cathode, oxygen will be reduced into oxide ions that can exist in solid electrolyte. But again, we know the overall reaction is producing water. So the anode reaction is hydrogen reacting with oxide to produce water. Okay, this is a little bit out of the realm of using cohees to balance, but because we know that in the end your overall reaction is this, it's kind of like you use this reaction to take away the cathode reaction to work out the anode reaction. Okay. So, as a summary, okay, overall reaction remains the same as if I change the fuels, and you will realize that even if you change up the electrolyte, it's still the same combustion reaction. Okay. Different half reactions happens depending on the electrolyte. Okay. Then you would ask, how do I know which one I'm writing for? So this is the tricky part. You will need to hunt for information on electrolyte in the questions. Sometimes it could be written as an alkaline fuel cell proved to be very efficient, or sometimes it could be written or given in the diagram. You have to be very careful. Okay? And the states of water in fuel cells can be liquid or gas. Again, you need to hunt for information in the questions to determine which one it is. But if nothing is given, i.e., no given reactions, not labeled in the diagrams, not described in the information in the first paragraph, then it is recommended that you write liquid so as to sync with your data book.